Hi, it's Jeff with Cribl. In this video, we're joining Randy Corelli as he talks through how to configure and use a REST collector to query the audit logs using the Cribl API and how to get the commit messages that are entered when stream configurations are saved. In this in-depth guide, he covers a lot of ground from event breaking, pipelines and routes, Cribl Lake, and even some finer points of REST collectors such as state tracking. Let's join Randy as he gives an office hour style walkthrough and demonstration.
Good day, everyone. On this video walkthrough, I'm going to go through setting up a REST collector on my Stream Worker Group to pull audit log details using the Cribl API. And in particular, we're going to look at getting the GIT commits. So the reason this one came up, a little background. Within search, we can find the commit messages with a search like I have here, looking at the audit log and the action being commit. But it is missing a little bit of detail, such as the actual changes within the files that were modified, as well as the commit message. So for those looking maybe a bit more enrichment on these ones, we're going to pull those logs in through the REST collector, do a bit of normalization in the pipeline, and then we're going to send it back to Cribl Lake here in my example. You, of course, could send your logs to anywhere that you'd like for analysis or storage. For mine, I'm keeping it kind of all within the Cribl ecosystem here. We're going to go back to Lake, those logs. So I'm not going to go through the finer process of how I created this REST collector. I'll do that in a separate video. But I did want to go through the two endpoints that we're going to pull from. So one is under the logging. We're going to use the system logs with the ID to get the contents of the log file. And this is where, with the appropriate filter, we can pull the detail of interest from a specific file, in our case, the audit log. And then each one of those results that we get back, we're going to call the GET endpoint here, called version show, which tells us here it gets the log message and the textual diff for a given commit. So with our commit as the parameter and the ID that we need, then we can actually go and get that finer detail for each Git commit that we have. For any authentication or just knowing the overall URL for your particular endpoint, you may want to review this top part here of the Cribl API reference. And if you haven't yet created any OAuth credentials in a Cribl Cloud environment, then you can do that simply by going to just your organization. Even here's products and organization, and then API credentials. And you can create a credential here with the appropriate access. So let's hop into it. For this one, it does have three components. So a event breaker rule, a pre-processing pipeline, and the REST collector as a source. So we're just going to go add rule set, manage as JSON, and here you could either import the file or we can just paste in our contents. And before we kind of go on, I just want to take a quick look down here at these fields. That's a little bit easier to see in this view than when we actually open up the event breaker. But here, in order to normalize the underscore time value that we'd like for our events, the detail for the date is provided within this commit message that is heavily encoded. So first, we're going to extract just the string for the date here into this double underscore commit underscore time field. The two underscores we'll keep it as an internal Cribl field, so we can reference it and use it, but it won't be sent to any downstream systems. So just kind of walking through what this does for those a little bit in the function. The JSON.parse on the underscore raw just turns that from a string to a proper JSON object, so we can reference this commit message field. And then we're just doing a regex replace to extract where we see the static date value. In the details here, we capture, and we can ignore the rest of this message. In these lines, I'll start with this %0a, which is a new line character. So that's where we use that as our boundary to basically find that line of the commit message. We trim off any white space, and then just replace the three encoded characters that matter in this timestamp. So the %20 is a space, %3a is a colon, and %2b is a plus sign. And once we have the normalized string version for the commit time, we can use these few functions here just to translate that into an epoch seconds. So this first one with the strip time here turns our string into a datetime object. And this is kind of the format for the data we would get back. And then the strip time function turns that datetime object and reformats it into the %s, which is epoch seconds. The final little bit of this function here, the number.parsent, just turns that output into a number versus a string. They may not be strictly needed, but I like to do that just for kind of consistency of having my underscore time be a number. So we're just going to go hit save, and we'll take a quick look at the other details here of this event breaker. So the filter condition is left to true. Since there's only one rule in the rule set, we can get away with this. If we ever add another rule, we'll need to make some conditions to apply them in the right situations. Otherwise, it's a pretty straightforward event breaker. We use the JSON array type, and the items field is where our data is. I've also increased the max event bytes to around 5 megabytes. The reason for that is with the JSON array, I don't want any truncation, because that would ruin the structure of the overall data and the breaking wouldn't work so well. And with these GIT commits, and the changes you make can both have a bit of data to them, but if you're committing a larger number of files, then that can also make the result set that we're pulling back be a bit larger. So in this case, I've kind of made it at 5 megabytes. That's probably a bit bigger than needed, but it was easy just to add 2 zeros here to the default 51,000 bytes. And that's kind of where we ended up. So feel free to adjust that a little bit if desired. Otherwise, that's why that one is set. And we've already looked down here at the fields that set our time for us. So that's kind of it for the event breaker and what that's doing. The next would be our pre-processing pipeline. And I'm going to do the same thing, just add pipeline. You, of course, could import from file, but I'm going to go through the manage JSON step and paste it in here. So here, and if we want to take a look at our simple file output, there's the preview. As far as input, we get this commit message object, and you can see here that that string, right, has a lot of URL encoding into it. And so that's what we want to normalize with this pipeline. The diff JSON, we're not really touching, but in some versions or some instances, I had found the underscore raw can be in an items array. So we do handle that situation just to make sure they're at the top level, like this input. The final output, and we'll kind of go through how we build that here in a moment. But for those maybe aren't interested, you can skip ahead. Here's the output that we end up with. And that commit message is now separated into the author email, the actual commit, author name, the commit date. And this is the same kind of format that we've extracted for our event breaker, the commit hash, and the default message or the commit message, which often in mine is just default commit. I'm also keeping the diff JSON, and I've pulled in 2 details from the discover step. One being the files that were modified, just as a little list. And the other one, the important one here, the Git ID, so we know which commit this log data came from. And to see those discover details, in case you wanted to persist more of them, if you just go to in after you've captured kind of your full run details here, you can go over to show internal fields, and it's in this collectible object, or this double underscore collectible object. So we see here the action was commit, the format of raw, etc. So there may be other details of interest in there for you. So let's just take a quick look now what we're actually doing in these 4 pipeline functions. So the first one, similar to what we did in the event breaker, it's just turning the underscore raw from a string into a JSON object. So we can see here that's a string, and now in the output, it's a nice JSON object. This makes it easier to work with when we're looking at these functions. This eval statement here is really just pulling out that commit message for us into a field we can work with without having to reference underscore raw or some process or chain through the event or the object. And this is also where it handles if there is that items array in the underscore raw, then it will bring the commit message out. And same thing with the diff JSON, it will bring that up to the top just underscore raw level if it isn't already at that level. Then we just remove a few fields here that we don't need just to help keep things nice and clean. This mask function, really just trying to translate in a few cases where we had multiple values or multiples of a character, so 2 or more, is what we're looking for here for both spaces as well as the new lines. And we're just going to remove if there are 2 or more and reduce them down to 1. And we do see here something like 4 of these %20s in a row, somewhere on one of these. There we go at the end. Right, there's 2 line breaks, which kind of makes it a little more of a pain when going through the array of data, and just these %20s, kind of a simple way of removing some white space. And then finally, this eval statement here is where most of the work is done. So we're going to first comment or disable all of these ones and just show how that commit message is more like an array of data. So I'm just going to remove that item from the remove fields as well, so it shows up here in my output. And there we now see that commit message that we had extracted before. We're first going to decode it, so get rid of all those HTTP encoding characters, trim it for white space, and then split it to the new lines. And that's where we have these 4 records with the commit hash, the author details, the date details, and a little bit more about the user and the commit message portion. So each of these, just go through them one by one from 0, 1, 2, 3 to the array references, just top to bottom, and extract that commit hash, the author, email, date, the author name, the commit message also from that one. And here's where we're also setting that GIT ID in our underscore raw object from the discover collectible and maintaining that files item. So just kind of a simple run through of what we're doing here. And I'm just going to go put that commit message back in here because we don't really need that once we've processed it. And that's really it for the pipeline. That just turns our kind of ugly commit message here, or very encoded commit message, just reformats that a little bit nicer into a nicer JSON object. You, of course, could do any additional normalization that you may want, including turning the underscore raw back into a stringified version, the JSON, modifying the diff JSON at all, or pulling out additional details, maybe up to the underscore raw, or even just trimming things that you may not need. So with the pipeline kind of ready, the next would be to go and add our REST collector. So again, I'm just going to add collector, configure as JSON, and paste this in. And we'll do a save here. So now, before we look at the discover and collect, the first would be the authentication. For Cribl Cloud, you would create that API credential for the OAuth authentication and just update your client secret value and your client ID value to match your credentials. But the URL, the grant type, and audience should all be set here as is, and that should be good for you. If you're an on-prem user for this one, you would just want to change that over to basic, and then the username and password for the login. The next one here to look at is the results. So for all the results we get back from the collect, this is the event breaker that we're going to send them through. This is the one we just imported. I also like to create this double underscore source underscore tag field. This just gives me something that I can use in my routes to help direct traffic a little bit easier, especially when I have multiple collectors. And I just put a simple value here to identify which collector it came from. And being an internal field, this won't get sent anywhere else, but makes it just a very quick reference for my routing. This, of course, is optional. You could use the collector ID as well. I just find that's a little bit more typing to put over in the route, or more looking to find it in the list. So I personally like this approach. So we're just going to send this to the routes. In this case, because we don't really need any additional processing, or at least not in my example, we could also just use the quick connect and send it to our destination. But we're going to send it to the routes, and the pre-processing pipeline, we have that enabled as the one that we imported. And don't let me change that. And there we go. So that's kind of it for the result set. The last bits of interest here would be the discover and collect steps. So in the discover, this is where we're going to, for a time range, pull out those GIT entries. And this was the log ID that we needed. And then, of course, this is the API endpoint, the system logs. And everywhere from the default to the beginning is what you would want to review and update as needed for your particular environment. Especially here, the cloud tenant reference, that will definitely not be the same as mine. Then you want to set just the earliest time that you'd like to start your logs from. In my example here, I'm going to go from January 13th, last Monday, till the current time here. So that's our latest time, just going to the current time, right? Date.now. The rest of this is just to set the filter that we want for our logs. In this case, it's the commit action. And we're going to limit it to the items that were modified within this worker group. So I do recommend setting up this REST collector for each worker group and having that similar kind of restriction. And that way each worker group will pull their own. And it just helps to make sure that when we actually request for the GIT ID, that we're also giving it the right group name so that those match and we don't get a not found error basically returned back. Afterwards, once we've set the state, we will come back and update this static starting point to use the stored state value. And that will make this perfectly dynamic so that each time it runs, we'll store the timestamp of the final event we processed, and we'll start the process from the next event in line afterwards. The rest of the portion here is just for the paging. So you can pretty much leave that as is, unless you want to adjust the page limit. Same thing here with the limit of records per page. But the discover data fields, this should already be set up. There's an items array that gets returned, and we want the events from within them. Then the collect step is very straightforward. This one here is where, again, you would need to just adjust this portion here for your particular environment. And we're going to do that version show API endpoint, passing it the ID of the GIT commit from the collect step or discover step. So each entry from the discover that gets returned will trigger a separate collect job to be run to pull its particular GIT details and send it through the pipeline. So before we do a couple of checks there, let me just go clear the state that I had here in my test environment. We're going to take a quick look just here at the routes. So for my basic route, I've used that source tag value here as my easy filter condition. We're going to do a pass-through, and for now, we're going to send it to dev null. But after we've done a couple of runs just to show what the kind of raw data looks like, then we will create our lake destination and go send data over there. So first, let's make sure that we commit and deploy all of our changes. That's very important, especially for the event breaker, so that the returned results get set in there. If we don't do that one, it will use the default event breaker, and it definitely doesn't do what we'd like it to. All right, let's give that a check and see where the workers are. So one's back. And there's two. All right, so with that back up and running, just give this one a quick refresh as well. Just something I like to do after the commit and deploys. And we're going to go here to capture. So I'm just going to stop that, and we're going to take a look. In this example, I want to first do it from the before the pre-processing pipeline. And actually, before we even get to this one, we can just do the discover step on here. So we're going to just do first a run and then discovery. And you could send it to the routes and do a capture. That's great if you want to save a sample file. But you can also just not change any of those settings and click run. And we can click this URL that shows up in the ad hoc run column. So here's our discover results. It returned 30 in this case. And we can see here the actions all commit. They're all from this collector. And if we expand any one of them, we can see what data is returned. The one that we really need for the collect step is this ID field. with that kind of hash value here. But that shows that that our login works and kind of tells us what we're getting back from our discover, so we can make sure that that's in alignment with what we expect for our collect step. Since that looks good, we're going to go back to our route, and now we're going to enable this capture and go do a full run. So run, full run. We won't enable the state tracking just yet. For this demonstration, we're just going to do a run. And here we see our events that come back. And we can see this looks very much like the output, or the input rather, that we had seen in our pipeline with this commit message and our diff JSON. So the collect step is in fact returning each of the entries that we'd like from our discover. And let's see if it got them all yet. It's gotten 28 of the 30. I'd say that's pretty close. The main one here is just showing that our collect step can run and that we have the correct parameters and things like that one. One more quick check. Let's just see if we got to 30 yet. Doesn't look like it. Oh, there it is. So we did get all 30 events show up here. So excellent. We kind of know it's working end to end here. So we don't have to worry about that part. So with that working, the next one would be just to get it going here with the dynamic state tracking. But before we do that, since we're actually going to pull the live data, in this case now, let's go set up our Cribl Lake dataset and destination here first. So for this one, it's pretty easy. Cribl Lake, we just go to our products and Lake, and then datasets. We can easily add a new dataset here, just GIT Commits. And we can set the retention period as desired. For mine, I'm just going to go with 7 days, and we're going to leave that here as a JSON format. And that's it. I have now created a new dataset that I can send data into. So of course, in our worker group, we also now need to make a destination. So within our destinations, we can find Cribl Lake, click Add Destination. Again, we give it an ID. Just going to go the simple GIT commits, and we select our Lake dataset from the drop-down list. You can review these other settings as desired, but that's all we really need here for this example. So we'll just click Save. And just like that, we now have a destination that we can leverage in our routes. So for it to show up here in our output list, we do want to give this page just a refresh and make sure it has the latest session details. And we go to the output, and we can see here Cribl Lake GIT commits. So we're going to set that, and we're going to do a save. And then we're going to do a commit and deploy. And then we're going to give that just a moment for the workers to get refreshed. Okay, so both of those are back online. Do that one more time. Then over here, I'm going to give this one a quick refresh as well. All right, then just to show that we are getting data through and the process data, we're just going to go here with the capture. And this time we're going to do it just anywhere after the pre-processing pipeline. So really, we can do before the destination. This is kind of what would be sent over to our Lake destination object. So we can start that one and do a run, full run. This time we will enable the state tracking. And the one portion we're going to change here is just removing this initial little check. So when the event breaker itself can set the underscore time from the events kind of automatically, then it will set this double underscore timestamp extracted field to true. Since we're doing it more manually, that may be false. And so I'm just going to remove that to guarantee that it's going to save my state value. We also know that the underscore time will always exist from this process because we're explicitly setting it in the event breaker. So we can click run. And then over here in our route, we should start to see our data. And again, worst case, if needed, we will just run that again. Looks like this one may have gotten a little stuck. And that happens a little bit here in my cloud environment when I do things directly after my commits, or maybe a little too quickly sometimes. So again, we're just going to do the full run, state tracking and enabled. And we're going to remove this little portion here. There we go. So now we're seeing events here. See if we get all 30. And since we did another commit and deploy, there may actually be 31. Guess that would have to run back to Monday for that one. We'll just wait and see if we get one more here. Yep, so we did get 31. And if we look here at our commit message, oh, there should be another one, because this was still default, and I had added a lake, I believe, or is that the previous one? No. So there should be around 30 to 32. Either way, we know that is working. Oh, and that's the oldest one. That's also probably why we're not seeing the message. There we go. So added lake destination was the message I expected. I forgot my newest event would be up here at the top. So next, we just want to verify that our state tracking that we stored has this value here, ending in the 8630. Just in case, we'll do a little zoom. We can see that number. We're just going to do a copy, and we can do a stop here. So back here on our REST collector, if we just do a refresh on the page, we'll see the Manage State button is now lit up, so it has a value. And if we go and take a comparison to the one we copied, now we can see that they now match. So that's great. It means our state time is properly getting set with the last event that we processed. And so our next step here would just be using this stored state, where we see here in this JSON, it's called latest time, within our collector itself. So we can go back into our REST collector. Our discover step is where this gets done. And we just want to replace that starting timestamp with the $ and the curly braces, and then state latest time. And we want to also add 1 to this. So if we start again from the actual latest time value, then we're going to repull this same event a second time, because that's this, right? This underscore time matches. So by increasing it by 1 second, we avoid repulling that last event, and we'll start from the next one in the sequence. So here we're just going to do a save. And we're going to commit deploy this one. And then again, we'll just give this a moment for the workers to refresh here. All right, so with those re-enabled, we're just going to give it maybe another couple of seconds just so that it's not too fresh after the restart. And I'm going to restart my capture again to see what we get here. And so now, just reconfirming, right, this is now dynamic on both. And if we do a run, full run, enable the state tracking again, and we'd get rid of that initial little check and click run again. So now over here in our routes, we see that that is a newer value. And if we expand our message, this is the last message I just put in, the enabled state tracking and the REST collector. So it did correctly pull my one latest Git commit, and it didn't pull any of the previous ones that we had before. So that really shows now it's working end to end with the state tracking enabled. The last little verification would just be coming back over here and looking at the managed state to make sure that it's got gotten updated to this newer value that we've pulled here. And we see there that it has. We can quickly just line that up to show that they're identical. So that further shows, right, things are working great end to end. The very last thing we would do here would just be in our schedule. Enable your schedule to run this at whatever frequency you would desire. And then just make sure to go down here into the state tracking, enable that, and make that same change we had been doing in our full runs of removing that little timestamp extracted check. And then once saved, you will now have this REST collector running on a 5-minute or scheduled interval to pull the latest commits and enrich them and send them off to your desired destination. I'm going to do one last little bit here of a search of our data set. If there isn't data here yet, then I will just pause the recording and come back once there is. So we can go here just to our data. And we see our GIT Commits data set down here at the bottom, and we can just click search. So it does usually take around 5 minutes to see data coming through. But here we already see those first few results have made it over. So just like our pipeline output had seen or a routing capture had shown, here's the data that we now would get in our search. If we wanted to include other data from the Discover, we could fill this out a little bit more to look and have the similar data as the original messages. But with the GIT ID, you should also be able to correlate between the two data sets and kind of put them together if needed. Otherwise, we now have this more enriched data with our message and other details in here that we could now build a dashboard or saved search, etc., as desired here. So I hope that helps to show this use case of using the Cribl API to pull things from the audit logs or any of the Cribl logs, and then being able to do a follow-up step, perhaps to enrich them. And I hope this was very useful. Thank you.
Thanks, Randy. If you want to learn more, you might want to look at our documentation at docs.cribl.io, or take a sandbox for a spin at sandbox.cribl.io. And last, please be a part of the community at community.cribl.io. As always, thank you for watching.